Hello friends, welcome once again. So I told you that there will be four parts of the derivations of trigonometric identities. But then I thought that I want these videos to be more than just derivations. I'm not just showing you the derivations of some certain identities. That would be sufficient in one video, one single video. I'm trying to give you a clear, concise explanation of all the basic concepts required for learning trigonometry. Trigonometry at a basic level. If you consider Indian education system, then trigonometry is required at say class 11th, 12th. But I'll not go into inverse trigonometric functions, and I'll just cover trigonometric identities in this you can say series, to use a strong word. So obviously if you see the previous four videos which are in my channel, you can go to the playlist section. There I have explained the concepts. I'm not just blindly derived the formulas. Anybody could do that. Okay, but yeah, I found that there are a few more things I would like to discuss. So here again is part 5. Well, I already said that part 4 will be the last part, so I'm sorry that I have to break my word. But this is part 5, and hopefully this will be the last part. So without further, let's start. So yeah, we already showed these derivations. Let's see it once more just in case. Okay, just in case. So suppose this is a right angle triangle. Okay, and let this angle be theta. Okay, so let this side be h, or the hypotenuse. Let this be the b, the base. And well, we can't say the height is h because I've already used h. Okay, so let the height be h, and let this be x. Let the hypotenuse be x. Okay. By the way, so this angle is 90 degree, and this angle we have assumed to be theta. That means this angle is automatically 90 minus theta. This, according to me, is the best, like easiest derivation of these things. Sine 90 minus theta is cos theta. How? Because sine 90 minus theta means we just consider this angle. Don't go into the details of 90 minus theta now. Just consider this angle. This angle is itself 90 minus theta in this triangle. So now, with respect to this angle, the opposite side is this. That's the b over x. And what is cos theta? Cos of theta, that's with respect to this angle, the adjacent side. We're considering cosine, so that means cosine is adjacent side over hypotenuse. That's just b over x. So they're equal. Sorry, the pen is a bit, the ink is a bit hard to understand, so I hope you can make it. Okay, so this is the basic thing, but now don't mind. But now the thing is that we consider these things, but the thing is that this is the concept of allied angles. But there can be many allied angles. For instance, if I have 90 plus theta, 180 minus theta. So for such angles there are actually some very short tricks which are helpful. Just by looking at the expression you can tell the example. But before that we must be very clear about one thing, that all we are dealing that in this concept we dealt with triangular trigonometry. That's trigonometry in a right angle triangle system. But that is not the best possible solution out there, because when you are considering a triangle, then like your values, the angles that you can choose, they are limited to acute angles, because see, you are considering a right angle triangle. So that means one angle is 90 degree. That means both this angle must be acute angle. None of them can be obtuse angle. So your values are limited from 0 degree to 90 degree. That too, you know the T ratios for certain values only: 0, 30, 45, 60 and 90. But if you consider circular trigonometry in a circular system, it's a much more better option. It's a much more better way to learn trigonometry. Consider a Cartesian plane and take the origin of that plane to be the center of the circle. Now you construct a circle. Okay. So yeah, we sometimes we use the concept of unit circle, but yeah, we just need to use the concept of circle. It's not necessary that the circle must be a unit circle. Okay. If we use the concept of unit circle, it's easier to understand. Like, it's easy. Okay. Now the basic thing is that if you consider, I hope you are knowing the concept of radian. By the way, I have made one video on radian, so I'll add that video too under the trigonometric playlist, because they are related. Okay, I'm just telling you about radian in short here, in case like it's inconvenient to go and check the video right now. So let this angle be theta. So theta is 1 radian. This is how we write 1 radian. See in the superscript. If and only if, let this be O, let this be A, let this be B. Length, I'm just writing L. Okay, length of arc AB, the length of this arc, okay, this length is equal to R, where R is the radius. These OA or OB both are equal, both are the right of the same circle, right? That means that 1 radian is that angle which the line which makes an angle 1 radian with this x-axis is the line which will the line will be such that this arc will, the length of the arc will exactly be 1 radian. And if you see once you move 180 degrees, in degree system this is 180 degree, right? Like this. That actually corresponds to pi radians, or just pi radians. Okay, why? Because obviously, see, 1, 2, 3 will be able to cover 3 radiuses, that means 3 radians till here, and some part will be left out. That's actually 3.14. And obviously, the circumference of the circle is given by 2 pi r. So yeah, once you consider complete a 360 degree rotation, that will correspond to 2 pi radians. So this diagram is very important. This is 0 degree. We always start from here. Okay. Now we always move by pi by 2 degrees. Pi by 2 is nothing but 90 degrees. Pi by 2 radians or 90 degrees. This is the factor by which we the consecutive angles. You can say this is an arithmetic progression. The first angle is 0 degree. The next angle is 0 plus pi by 2 degrees. Then is 0 plus pi by 2 plus pi by 2 and so on. I think you know the concept of arithmetic progression. Even if you don't know, that doesn't matter. So this will be 90 degrees or pi by 2. This will just be pi, 90 degrees or pi by 2 radians. This will be your 180 degrees or pi, just pi radians. This will be your 270 degrees or 3 pi by 2 radians. And this will be your 2 pi radians or 360 degree. 360 degree corresponds to 0 degree. And you can just move on again. You can add 90 to 360. Just the same cycle can make continue endlessly. Okay. Well, the thing is that. Okay, that's all. So now I would like to tell you the new definition of sine and cosine. So in triangular system, we have been seeing that sine is the opposite side. Sine of an angle is the side opposite to the angle. By the hypotenuse, divided by the hypotenuse. Like say in this triangle, sine theta would be like this length over this length, right? So that's why any point on the circle, the coordinates are cos theta comma sine theta. Because you see nicely, sine theta is this over this. If we assume it to be unit circle, then the radius is just 1. So forget about the radius right now. So this here is just the coordinate on the y-axis, right? Because this line here and this length are the same. So let this be say C. So AB and CO are the same length, right? So that's what I'm trying to say. That means sine basically corresponds to y coordinate. That's why sine theta, and cos theta is just this by this. So the hypotenuse is 1. So we just consider this length here. This is just the x coordinate, not OB. This length. Let's say this is C here. Not this is not C in this case. So OC here. OC by O is cos theta, right? But a more beautiful, a more nice definition of sine theta and cos theta in circular system of trigonometry would be just to consider a circle here. Just draw any radius, okay, such that this angle is say theta. So what is sine theta? Sine theta would be the projection of this radius. Understand nicely, the projection of this radius on y-axis. This is y-axis and this is your x-axis, right? So if I shine light from this direction, like I'm shining light, okay, I'm just seeing it from this direction. So if I see it just from this direction, I will not be able to understand whether the line is slanted or not, because I'm just seeing it from the front. To me it will appear as a straight line. That's what I mean by projection. So projection of this line here, this radius here on the y-axis will just be this, like just draw a line parallel to the x-axis. So this length, this is what I'm trying to say. Let this be x. So here, no, we can't use x. So let this be p. Okay, I'm just the entire length, the projection. Okay. So projection by this, let this be radius by r. So p by r is what you call sine theta in such systems. Cos theta similarly projection of the same radius on the x-axis, like when you are shining light from above. Like draw a line parallel to the y-axis and this length here, say p2. So cos theta would be p2 over r. The r is not changing obviously. Now please make this, you may see the video once again, you may rewind, but make this concept very clear. Okay, right, now we may consider the interesting question. What is sine 90 plus theta? Now we know sine 90 minus theta is cos theta, but what is sine 90 plus theta? Well, this also comes out to be cos theta, but let's see how. And sorry, before we move forward, just one more concept. I hope you're knowing the basic things. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. So one nice tip I can give you, just remember this line: all school to college. From school we move on to college, right? So just remember this simple statement: all school to college. Now how this will be, you certainly wonder why I am telling all these things. I'm teaching you trigonometry. Thing is that in the first quadrant, you see both the x-axis, I mean this part of the x-axis and this part of the y-axis, both are positive. So sine theta corresponds with this, that sine theta will be positive, cos theta will also be positive, tan theta is just sine over cos, which will again be positive, and all the other things are just, you can derive the other things from these things, right? So they will also be positive. So in the first quadrant, all trigonometric ratios, sine, cos, tan, whatever, they are positive. The value of them is positive if the angle lies in the first quadrant. So that's why all, just A for all, okay. In the second quadrant, S, only sine is positive, only sine. That means cos and cosine and tangent, they are negative in the second quadrant, okay. Why? Because see, in this case the y-axis is still positive, so that's why sine is positive. But see, the cosine will become negative because the x-axis is negative, and tangent will be sine over cos, which will be negative, obviously. In the third quadrant, all sine, this is t, so only tangent is positive. Only tangent is positive in the third quadrant. Why? Because see, in this case both the sine and cos are negative. Both, this is the negative y-axis and negative x-axis. But when you divide them, sine over cos, you get a positive result, right? That's what I mean by tan. And in the fourth quadrant, well, see, only cosine is positive. Why? Because it's obvious. In this case, cosine corresponds to x-axis. In this case, the y-axis is negative, but the x-axis is positive. So only cosine will be positive. By the way, here see, tan is positive. So 1 by tan, that's cot will also be positive. Doesn't matter. That means you can say that cot is also positive in the third quadrant. Doesn't matter. Here we are only considering sine, tan, and cos. So when I say all, that means among sine, tan, and cos. So that's, you don't need to go into the cot, cosec, and all those things. These are the basic. Sine, tan, and cos are the basic. So we have already discussed those identities. Sine of a plus b is sine a cos b plus cos a sine b and all those things. But now we'll see how sine of 90 plus theta. Okay, let's just find out what sine of 90 plus theta is. At last, let's draw a circle. So let this angle here be theta. Okay. Okay, fine. Now do one thing. You do one thing. You just add 90 here. Okay. I mean this angle is here, so let this angle be 90 degree. And this angle again is also 90 degree. I hope you know what I mean, right? So the meaning of this is that this entire angle here will just be 90 plus theta. Okay, so yeah, that's what I'm trying to mean. This is so this entire angle, I mean this entire angle. Okay, this will be 90 plus theta. We need to find the sine of this angle. So as per the new definition, let's just do some few constructions first of all. I think that would suffice. Now look at these two triangles first of all. This angle is 90 degree, this angle is 90 degree, right? And both of these lengths will be same because they are the radii of the same circle. They don't seem to be equal here, but they are the radiuses of the radii of the same circle. So obviously they will be equal. They will be equal. And what else? See, basically this angle is theta, and this angle is also theta, right? This angle is also theta. And yeah, this here is 90, and this here is also 90. You can say separately. So see, basically both these angles are also equal. That means these two triangles are congruent. So see, I need basically to find a sine. So this will just be projection on the x-axis, so this length. Okay, so now let this be O, let this be A. So OA upon the radius, I'm just naming it as R. This is also R, this is also R, doesn't matter. Now in place of OA, I can write this thing here because see, basically the same thing, right? These two triangles are congruent, I already proved. So let this be B. So this I can also write this as OB by R. Now what is OB by R? See, in this triangle, this is also theta. So from the point of view of this theta, OB by R is the adjacent side about the hypotenuse. So this is just cos theta. Simple derivation. Now, so if anybody asks you some questions, say the sine of say 120, so that time it is 90 plus 30. Now you know what sine of 30, what cos of 30 is. So you can, so this is how we solve such questions. So sine of 90 plus theta is cos theta, sine of 90 minus theta is also cos theta. This is how we solve it. What else? Let's look at cos of 90 plus theta. Okay, no problem. So if you have cos of 90 plus theta, this will turn out to be minus sine theta, negative sine theta. Let's see how. Let's see how. This looks a bit untidy. Let's draw a new diagram for cos. So same thing. Let this be theta and just constant 90 degree here, and let this also be theta. So anyway, you know what I mean. So when I need to find the cos, that means it is this here, this length here. I mean this length and this length are equal. Position of the x-axis. So let this be O. So let this be A. So that is OA over R radius. But you see, this is the negative x-axis, so we will have a minus here. Okay, so that's why we have a minus here anyway. So now again these two triangles are congruent. Now this length is equal to this length. Like you can just rotate the triangle and see what I mean. So this length is also equal to this length, so we can replace this by that. Let this be CD. So this is just minus CD over R over this. So this is just sine theta in this triangle. But yeah, we have a minus here. So this here is sine theta in this triangle, obviously. So minus sine theta. Derivations are really simple. Once you get the concept, derivations are really simple. So sine of 90 plus theta is cos theta. Cos of 90 plus theta is minus sine theta. Now if you have done derivative, you might see something here. ddx of sine x is cos x and ddx of cos x is minus sine x. So there is a, like, you know what I mean, you can if you are very familiar with derivatives, you can use that trick to remember this, or vice versa. Okay, now let's find, and we already know that cos of 90 minus theta is just sine theta itself, just positive sine theta, in that case it will be. And tan, okay, tan of 90 plus theta will just be this by this, right? Just the sine over cos, so if you just divide them, you see that is cos theta over sine theta, but we will have a minus here nevertheless. So minus cot theta, cos theta over sine theta is cot theta, right? Tan of 90 plus theta is cot theta. That's clear. I think this is till here it's clear. Now let's consider 180. Sine of 180 plus theta. This is a bit like, or first let's consider 180 minus theta. Now 180 is a multiple of 90. That's why all these we are considering, they are all allied angles. But still 180 is a like a bit tricky. So let's see how to do sine of 180 minus theta. In this case we consider this diagram. So first start from here, go 180 degrees, so you end up here. Now okay, you're doing minus theta in this case, right? So by the way, I think you're knowing this thing. So if you move an angle to this direction, then that's called positive angle, and if you move an angle to in the clockwise direction, then that's a negative angle. So yeah, if you do minus, you will end up somewhere in the second quadrant, right? So we have to find the sine. Okay. So let's try to understand the situation that we're having. It will basically be, if you just draw this triangle, okay, you don't need to join this anyway. So you need to consider this angle entirely, and you can also let this angle to be like theta. So basically in this case, you need to consider the congruency between these two triangles, this here and this here, right? So once you do that, you see that sine, it is just the position of the x-axis of this or this same thing. So basically this by this. Now what is this by this? From the point of view of this triangle here, in the second triangle, this by this is again just sine theta. So sine of 180 minus theta will just be sine theta itself. Sine of 180 minus theta will be sine theta. Okay, and yeah, you can prove these two triangles are congruent. We have a 90 degree here, and all these things are radius, and yeah, this angle we have already taken to be theta. Okay, so see how this is coming. First of all, we move 180 degree, and then we moved 180 degree. Then we subtract theta. So this angle here is 180 minus theta. This angle here, okay? I mean this angle. You know what I mean? I think you know what I mean. And yeah, you can also let this angle be theta. So you can just do the same thing from the other direction also. If we started from this direction, then this angle could be theta. So if we move theta, then this angle will be 180 minus theta. Same thing. So by that way, you can prove this triangle to be congruent. So like this, you can derive all these things. So I will not be showing you the derivation for all these things. But yeah, and yeah, for sine 180 plus theta, we would have started, okay, let's draw the circle. We would have ended up somewhere in the third quadrant. First we move 180 degree, some here, then plus theta. So this angle here would be theta, right? Okay, that's fine. So this case, you see, basically you can just join this and you can like extend this. So let this also be theta, okay? Same concept, I'm just using the same concept. So you see this triangle here, I'm just shading this. This triangle here will be congruent to this triangle, because both these angles are theta and we have an 90 degree, and the radius of the same circle concept will also apply here. And anyway, these are vertical opposite angles in this case. Okay, so we need to find sine. So sine means this, or in this case we can also say this over this. Now this over this, what's that? This over this, that's again sine theta, right? Right? No. Yeah, that is sine theta, but be very careful. We ended up in the third quadrant. So in the third quadrant, all school 2 college. So in the third quadrant, tan is positive, but sine is negative. So negative sine theta. Sine of 180 plus theta is negative sine theta, but sine of 180 minus theta is sine theta. And for cos, I'm not deriving. You see these things. Cos of 180 minus theta and cos of 180 plus theta, right? So cos of 180 minus theta is minus cos theta, and cos of 180 plus theta is also negative cos theta. Negative cos theta, negative cos theta. So how are you determining this sign, whether it will be positive or negative? That you can determine by that rule, all school to college. On which quadrant the final angle lies. You have to consider that quadrant. Okay, from that. Now all these things, you do not need to derive all these things every time. There are simple rules, and I will be telling you shortly. So if you use odd multiples of 90, so this is just 90 multiplied by 1. 1 is a odd, well, 1 is not, anyway, here 1 is an odd number. So if you use odd multiples of 90, 90 or say 90 into 3, 270, the 90 into 3 is 270, or say 90 into 5, in that case that thing plus theta or minus theta doesn't matter really. So in that case your function will be reversed in the sense, if it was sine, sine will become cos, sine will become cosine, tan will become cotangent or cot, and sec will become cosecant, and vice versa. Okay, if odd multiples of 90, and if even multiples of 90, for instance 120, it's 90 times 2, it's an even multiples of 90. Or even if we have 0, very important concept, because 360 is that's it, 90 times 4, which is 4 is even number, and you see I already showed you the diagram, 360 corresponds to 0, so 0 can also be, so 360 can be written as 2 pi. So that is, so from here we get a very important result. If we have sine, not just sine, first of all let's write for sine, 2 pi n plus theta, we can just simply write sine theta, because this here is going to be 0, 2 pi corresponds to 0, and 0 multiplied by anything is just 0, so 0 plus theta is just theta. Similarly cos 2 pi n or 2n pi, but I am writing 2 pi so that it's easier for, oh by the way you can't see here, right, sorry. So sine 2 pi n or 2n pi, so this is due to this 2 pi, plus theta is just sine theta. Similarly cos 2 pi, now cos 0 is 1, but don't get confused by this is just cos theta, because first of all you forget whether it's a sine or cos or tan. First you consider the bracket, so in the bracket you see we have 2 pi n, so just forget this term, so that means this is equivalent to 0 plus theta, that's why it's 0 plus theta, so that means just theta. So now you don't need to apply cos 0 or sine 0, okay. And similarly for tan also, tan 2n pi or 2 pi n plus theta is tan theta. Very important results. Okay, so let me clean the board. So that's our short trick for all odd multiples of 90. Thus function will become its like sine will become cosine. I'm just writing a reverse for short. Tan will become cotangent, and sec will become cosec. And for all even multiples of 90, no reversal. But yeah, you need to do whether it will be negative or positive, the sign before the function, whether that will be negative or positive. For that you need to consider like the concept of quadrants. Now for that you don't need to draw the diagram. Basically once you do a little bit of practice, it becomes like obvious. You have the intuition, like 270 degree, okay, so let's say 265, that will lie in the third quadrant, right? So you have that intuition, greater than 270, lesser than 360 in the fourth quadrant. So just remember this figure, 0, 90, 180, 270, 360. That will do. So for instance, with this trick you can solve anything. For instance, if we have cos 270 is an odd multiple, right, minus theta, let's say, whether it's a minus here or plus, it doesn't matter. Yeah, it matters, obviously it matters, because that will determine the quadrant basically. So 270, it's a 90 times 3, that's an odd multiple of 90. So for odd multiples of 90, reverse, so we will have some sine theta here, okay. And whether positive or negative, whether positive or negative sine theta, for that I'm just drawing the diagram in this case. 270 is this here, this right here, like we move 270 degrees, but minus theta, so in which direction our final angle will like reverse. excuse me, so our final angle will come a bit towards, like will move a bit anti-clockwise, and it will end up here in the third quadrant. So all school to college, in the third quadrant tangent is positive, only tangent, that means cosine is negative, so negative sine theta. That's how you remember, just simple one line proof, right? And yeah, if it was 270 plus theta, if it was, in that case 270 would have added theta here, so it would have moved in the anti-clockwise direction. Sorry, this was clockwise, in this case it would have moved in the anti-clockwise direction. Anyway, so in this case it would have ended up in the fourth quadrant. So all school to college, in the fourth quadrant cos is positive, so positive sine theta in that case. So to remember these simple things, and it's really enjoyable, and obviously there's much more trigonometry than these things, but yeah, these things are very enjoyable and these are required, these are the basics, okay. Well, and yeah, by the way, I already showed the derivation. Geometric derivation of cos minus theta is just cos theta, and sine minus theta is negative sine theta. Sine of minus theta is negative sine theta. And once you know these two, you can easily find out for tangent, cotangent, and so on and so forth, right? So how to I showed you this one, right? As far as I can remember, this is plus x, this is minus x, and you can change the coordinates. That's a really nice way of looking at the situation. But yeah, from this concept also you can find this. This is just write this as 0 minus theta. Now 0 is just 2 pi minus theta, or just 360 minus theta. So anyway, this will be an even multiple of 90, or you can also say 0 times 90. 0 can be considered even number here, right? So even multiples of 90, it will not be changed, so it will have cos theta here. Now positive or negative, well, positive or negative, for that you consider minus theta here, right? So 0 minus theta, so basically we have minus theta here. See, if for cos you will have a positive result, because 0 corresponds to 360, so let's move 360 degrees, okay? But minus theta, so if we subtract theta, we move a bit in this direction, we end up with the fourth quadrant, where all school to college, in the fourth quadrant cos is positive. So yeah, that's why cos of minus theta is plus cos theta. Similarly, consider this thing, sine of minus theta can be written as sine of 0 minus theta, which is again we are applying the same concept. So here, but if we will end up with the same position, doesn't matter. But now we are considering a sine function. So in fourth quadrant, sine is not positive, sine is negative. So anyway, we'll have negative, and as it is a even multiple of 9, the function will not be reversed; it will stay as it is. So negative sine theta. Simple derivation. So yeah, there are many ways to derive these things, and once you get the hold of it, it's really enjoyable. It's nice to experiment with these things. Now I want to show you a few more identities. These are not standard identities. We have already covered the standard identities in the previous videos, but these identities are really useful in solving certain questions. So we just quickly solve some identities. Solve means derive some identities. Okay, I'll not be solving the questions here. Okay, sine 2a. We all know what sine 2a is, but here we can also write it in terms of tan. Say someone is asking to write this in terms of tan a. What to do? So what is sine 2a? That is sine of a plus a. All these formulas I will be using. You can see the derivations in those past 4 videos. I'll be adding the link in the description. Don't worry. So sine of a plus b is sine a cos b. That's in this case sine a cos a only. Plus cos a sine b. So plus cos a sine a. That is 2 sine a cos a. Right. So basically we have 2 sine a cos a and by 1. Let's say. Actually, this is a way to represent. Now divide both numerator and denominator by sec square theta, or sec square a in this case. Now we already know that sec square a minus tan square a equal to 1 is equal to 1. So sec square a can be written as 1 plus tan square a. So yeah, in the denominator we have 1 plus tan square a. That's in terms of a, alright. That's in terms of tan a, alright. 1 plus tan square. Now in the numerator you see basically what is sec. Sec theta is 1 by cos theta. So we have 2 sine a cos a divided by cos a cos a. We'll have 2 cos a, right, because we have sec square a. So yeah, the expression will simplify here. So now sine a by cos a is tan a. So 2 tan a over 1 plus tan square. We can also write sine 2a. Okay, this expression here as 2 tan a over 1 plus tan square. And similarly, if we solve for cos 2a, I am not solving it because we have limited time here. But yeah, if we solve for cos 2a in the similar way, you just divide both the sides by sec square a. In that case, you will end up with 1 minus tan square over 1 plus tan square. Now you may rationalize this or you may not. Denominator will obviously be 1 plus tan square, and yeah, in this case you will end up with 1 minus tan square. Now we will be dealing with 3 more identities before ending of this video. These are not identities actually. These are not standard identities, and you can yourself derive this. For instance, if I ask the value of sine of 3a in terms of sine. There are many ways to obtain an expression for this, but yeah, in terms of sine we need. So what is sine 3a can be written as? Just choose your values as convenient. So in this case, obviously we have to write it as 2a plus a. So we know what sine 2a is, so I'm not separately deriving it. It's just 2 sine a cos a. So 2 sine a cos a. What is sine a? Sine of a plus b. Sine a cos b. So this here, this is the sine of 2a here. Cos of a. Here a is in the same position as b. Plus cos a sin b. So cos 2a and sin a. Now cos 2a basically see it can be written in many forms because I'm just writing it once more. If you don't know the formula derivations, you can once more you can check out those videos. So what will be cos of a plus b? It will be just cos a cos b minus sin a sin b. And if we had cos of a minus b, then we would have a plus here. So if we had cos of a plus a, cos of 2a which we have here, this would be cos square a minus sin square a. So we need an expression in terms of sin square. So cos square is 1 minus sin square because obviously from Pythagorean identities. So 1 minus 2 sin square. 1 minus sin square minus sin square. That means 1 minus 2 sin square. So that means sine of 3a is 2 sin a cos square a. 2 sin a cos square a because we have 2 cos's here. Plus 1 minus 2 sin square a, right? Plus 1 minus 2 sin square a. And here we have a sin a to multiply this with. So that excuse me. So that is just 2 sin a cos square a plus sin a minus 2 sin cube a, right? And yeah, so this cos square can be written as 1 minus sine square. So 1 minus sine square. So 2 sine A minus 2 sine cube A, and we have minus 2 sine cube A, so minus 4 sine cube A and plus sine A. So 3 sine A minus 4 sine cube A, that's a formula. 3 sine A, yeah, minus 4 sine cube A. Similarly, you can solve for cos 3A. I'm not showing the derivation here. You will end up with 4 cos cube A minus 3 cos A. 4 cos cube A minus 3 cos. You don't need to remember this. Please don't remember these formulas. You can just derive it. I hate the idea. Please don't remember these formulas. And tan 3 you can just divide other ways also to reach other result. So let's anyway, let's solve for tan 3, because it will be interesting. That's the last calculation we'll do this video, and then we'll end up with this video. So tan 3a is tan of 2a plus a. So what is tan of a plus b? Tan a plus tan b, that is tan 2a plus tan a over 1 plus tan a tan b. That means in this case tan 2a tan a. Now what is tan 2 in case you don't know? This can just be written as tan of a plus a, which will give you tan a plus tan a, that's 2 tan a over 1 plus tan a tan a, that's 1 plus tan square a. 1 plus tan square is just sec square a, but here we need to represent it in terms of tan square a, right? So 2 tan a over 1 plus tan square a, we can replace it here. 2 tan a over 1 plus tan square a plus tan a. So this is one numerator, let's solve. This will be 2 tan a plus, if you multiply, tan a plus tan cube a over 1 plus tan square a. Okay, and now let's solve separately for the denominator, separately. So 1 plus tan 2a is just 2 tan a over 1 plus tan square a times tan a. So we'll have 2 tan square a in the numerator in this case, just for the second term. So that is 1 plus tan square a plus 2 tan square a, that's 1 plus 3 tan square a, right? Yeah, over 1 plus tan square a. So now once you divide these two terms, the 1 plus tan square and 1 plus tan square will just cancel each other out. So all we have is 2 tan a plus tan a, so this is just 3 tan a plus tan cube a, right? So 3 tan a plus tan cube a over 1 plus 3 tan square a. Let's check it out. 3 tan a. Will we have a minus here? Sorry. I'm extremely sorry. For we have a minus here. 1 minus tan square a. Actually, this is a common mistake. I do this quite sometimes. Tan of a plus b is tan a plus tan b over 1 minus tan a tan b. So yeah, you will get a minus here. All this will become minus. You can check it there, which I'm not showing it once more. So I'm just writing this very clearly. Maybe you also have the same problem because many students have a tendency to do a mistake here. So tan of a plus b is tan a plus tan b over 1 minus, this is not plus, okay, tan a tan b. And if we had tan of a minus b, that would have given you tan a minus tan b over 1 plus tan a tan b, as far as I can remember, yeah. So that was all about trigonometric identities 5. That's all. The series of this 5